Imagine just taking a second to look really closely at your own hand right now.
Yeah, just right in front of you.
Right. You see the texture of your skin, the lines on your palm, maybe a small scar. It feels completely solid.
Like a definitive physical object.
Exactly. But if you were to somehow zoom in, past the cells, past the molecules, deep into the actual atomic structure, that solidity just completely vanishes.
It's gone. It totally evaporates.
Yeah. You wouldn't find these tiny, hard billiard balls making up your flesh. Instead, you'd find these vast, honestly kind of terrifying expanses of completely empty space.
Right, space that's just sparsely populated by these swirling, indeterminate clouds of probability.
It's wild to think about. The closer you look at reality, the less there actually is. It dissolves from this dependable thing into a strange mathematical phantom.
Which is deeply unsettling for most people.
Oh, absolutely. And that realization that reality isn't as solid or neatly categorized as we desperately want it to be, that is exactly where we're starting today.
It's a huge jumping off point. It really is. Welcome in to you, the learner. We are so thrilled you're here with us today.
The premise for today's deep dive is an absolute mind-bender.
To say the least.
Right. I mean, the very device you are using right now to listen to this audio relies entirely on a field of science so utterly bizarre that its own founders felt like reality itself was slipping through their fingers.
Yeah, the historical record actually shows they were genuinely distressed by their own equations. I mean, mathematics of quantum mechanics.
The same math that gave us, modern computing and MRI machines?
Exactly. Global communication networks, all of it. That exact same math completely dismantled our foundational understanding of what a physical object even is.
It's just staggering.
Yeah.
So what is our mission today? Well, we've got a massive, incredibly fascinating stack of sources laid out here.
We're really running the gamut today.
We are. We're pulling from theoretical physics texts, ancient philosophical treatises, and some really sharp modern critiques.
Yeah, we're looking at Carlo Rovelli's Breakdown in Helgoland, Fritjof Capra's classic The Tao of Physics.
And deep analyses of Buddhist ontology, plus some essays unpacking the trap of what they call quantum mysticism.
Which is a very real trap, by the way.
Oh, for sure. So our mission is to explore these uncanny, almost eerie parallels between the bleeding edge of quantum physics and the ancient wisdom of Eastern philosophy.
And we're also throwing in a connection to artistic movements.
Yes. Like Cubism, just to give us a visual bridge to really grasp the physics.
But, I mean, we should establish the parameters of this deep dive right up front. Because the waters we are entering here are, well, they're treacherous.
Yeah, you have to be careful.
Extremely. While the parallels between these disciplines are profound, they are heavily infested with pseudoscience. It is remarkably easy to take a truth about subatomic particles and twist it into...
And hope nonsense.
Basically, yeah.
Yeah.
What the Nobel Prize-winning physicist Murray Gell-Mann famously called quantum flapdoodle.
Quantum flapdoodle. I love that term.
It's perfect. So our objective today is to extract the genuine, logically sound insights from these sources without falling into the trap of New Age wishful thinking.
Right. No logical leaps here. So buckle up, learner. I can promise you that by the time we wrap up this conversation, the way you view a simple, everyday physical object...
Like a screen you're looking at right now.
Exactly. Or the chair you're sitting on, it will be fundamentally, permanently altered.
But to really appreciate the sheer magnitude of this shift, we first have to examine the worldview that quantum mechanics destroyed.
Right. The classical view.
Yeah, for centuries, the Western scientific consensus was entirely dominated by the paradigm established by Isaac Newton.
The good old classical clockwork universe. Let's really paint a picture of what that meant for, the average person's understanding of reality.
Well, in the Newtonian framework, the universe was envisioned as this giant deterministic machine. It was composed of solid, independent objects moving through a passive, empty void.
Like years in a clock.
Exactly. Newton proposed absolute space and absolute time, like a fixed stage where the drama of matter just played out. And the most comforting aspect of this was its strict determinism.
Right, the predictability of it all. Which brings us to Laplace's demon, right?
Yes, Pierre-Simon Laplace. He suggested that if an intellect existed that knew the precise position and momentum of every single particle in the universe at a given moment.
And understood all the forces acting on them, right?
Right. Then that intellect could calculate the entire past and the entire future of the universe with absolute certainty.
It's a universe of ultimate predictability. Everything is just an isolated thing bumping into other things according to fixed laws.
But that mechanical, highly predictable universe began to show serious cracks at the dawn of the 20th century.
Because when physicists started looking really closely at the structure of the atom, those classical laws simply stopped working.
They fell apart completely.
Which brings us to this pivotal historical moment in our sources. It's the summer of 1925.
Yeah, let's set the scene here, because the context is so crucial.
Okay, so there's this 23-year-old German physicist named Werner Heisenberg, and he is suffering from an absolutely crippling bout of hay fever.
Like debilitating.
His face is swollen, he can barely see, and just to escape the pollen on the mainland, he retreats to Helgoland, which is this barren, treeless, wind-battered rock of an island in the North Sea.
And the isolation of that environment perfectly mirrors the intellectual isolation he was feeling. He was grappling with a fatal flaw in the reigning model of the atom.
Because at the time, physicists envisioned the atom as a miniature solar system, right?
Yeah, following the work of Ernest Rutherford and Niels Bohr, you had a dense nucleus in the center, and electrons orbiting around it like tiny planets.
Which, I mean, that sounds perfectly reasonable to our Newtonian brains.
It sounds totally reasonable until you actually apply classical electromagnetism to it.
Oh, right.
Because according to the established laws of physics back then, any charged particle that is accelerating, and by the way, moving in a circular orbit, is a constant state of acceleration.
It has to emit electromagnetic radiation.
Exactly. If an electron is orbiting a nucleus, it should be continuously radiating energy.
And if it's losing energy constantly, its orbit should decay. It should just spiral inward.
Rapidly. I mean, a classical electron would spiral into the nucleus in a fraction of a second.
Wait, so if the classical model were correct, all matter in the universe should instantly collapse.
Literally instantly. Atoms shouldn't even exist. Yet, here we are.
Wow.
And furthermore, when atoms emitted light, they didn't emit a continuous rainbow of colors, which is what a spiraling electron would produce.
They emitted those very specific, discrete frequencies, right? Distinct spectral lines.
Exactly. So, isolated on this pollen-free rock, Heisenberg is pacing the island during sleepless nights, and he decides to perform this radical epistemological surgery.
He just completely throws out the visual model.
He stops trying to picture what the electron is doing behind the scenes. He completely discards the concept of an unobservable continuous orbit.
He focuses strictly on what he can actually measure.
Right? Exclusively on the frequencies of light emitted or absorbed when an electron jumps from one energy state to another. And he builds this complex mathematical framework based entirely on those observable transitions.
Arranging that data into arrays of numbers that we now call matrices.
Matrix mechanics. And the math contained a shocking feature. When you multiply these matrices together, the order mattered.
Which is weird, right? Because normally A times B is the same as B times A.
Exactly. But here, A times B did not equal B times A. This non-commutativity was mathematically translating to a crazy physical reality.
Which is that you cannot simultaneously know both the precise position and the precise momentum of a particle.
The famous uncertainty principle. It completely shatters Laplace's demon right there.
Because if you can't even know the present state of a single particle, you definitely can't predict the future of the universe.
But the philosophical consequence is even more staggering than that. The math was telling Heisenberg that particles don't actually have definite properties.
It's like a fixed position or a specific velocity.
Right, they don't have those properties until they interact with something else or are observed. Before that measurement, an electron isn't a tiny solid billiard ball sitting in a specific spot.
It just exists as a wave of probability.
It was the definitive end of the classical era. Reality at the fundamental level was revealed to be probabilistic, not deterministic.
But the deeper and honestly more unsettling revelation was about intrinsic properties. The Newtonian assumption was that a thing possesses its properties completely independently of the rest of the universe.
Right, an apple is red and weighs a certain amount whether it's sitting on a table or just floating in a void.
But Heisenberg's framework suggested that an electron doesn't possess a definitive position or momentum in isolation at all.
It only acquires those properties contextually through an interaction with another physical system.
So to make this abstract physics a bit more tangible for you, learner, let's look at an analogy drawn from the art world.
The cubism analogy is perfect here.
It really is. Think of classical Newtonian physics like a traditional Renaissance painting. Like if you look at Leonardo da Vinci's The Last Supper.
There is a single, absolute, fixed perspective.
Yes, the artist uses a geometric vanishing point to present the world as an objective reality. You are simply looking through a window at a scene that exists independently of you.
The underlying assumption is that there is one singular, objective way the world is that maps perfectly onto the classical assumption of an absolute God's eye viewpoint.
Exactly. But now compare that to the quantum realm Heisenberg uncovered. That realm is much better represented by a cubist painting.
Like Pablo Picasso's Les Demoiselles d'Avignon.
Or the works of Georges Braque. Cubism violently shatters the tyranny of that single absolute viewpoint.
When you look at a cubist painting of a violin, you aren't seeing it from one fixed, quote-unquote, true angle.
Right. The canvas presents the front, the side, the back, and the top of the violin, all fractured and overlaid at the same time.
It forces you to abandon the idea that the object has a single, absolute visual form independent of the observer's perspective. You are looking at multiple relational facets interacting all at once.
And that artistic revolution happening in the early 20th century perfectly mirrors the scientific revolution of the exact same era.
And it does. And this analogy leads us directly into the work of theoretical physicist Carlo Rovelli, which is a primary focus of our source material today.
Rovelli champions an interpretation known as relational quantum mechanics, or RQM, right?
Yes. He takes the implications of Heisenberg's mathematical matrices to their ultimate logical extreme. Just as cubism demonstrates that form depends entirely on the angle of interaction, Rovelli argues that at a fundamental physical level, there are no absolute objects whatsoever.
Wait, none.
None. There are only relations.
I really want to pause on that statement because saying there are no absolute objects is a massive, incredibly counterintuitive claim to make about the universe.
It requires a complete rewiring of our intuition. But Rovelli uses a highly grounded everyday example to illustrate this.
The chair example.
Yes. Consider the chair you are sitting on right now. Your everyday intuition tells you that this chair is a solid, objective entity that possesses certain intrinsic, inherent properties.
Like its color. Let's assume the chair is bright red.
In the classical view, redness is a property belonging to the chair. The chair owns the red.
Right. If I turn off the lights and leave the room, I just naturally assume the chair sitting in the dark is still structurally a red chair.
But Rovelli dismantles that assumption by breaking down the actual physics of vision. The chair's color does not exist in isolation.
Red is not a property residing inside the matter of the chair.
No. Think about the mechanical process required for color to exist. First, you need an electromagnetic wave light hitting the chair.
And the specific molecular structure of the paint on the chair absorbs certain wavelengths of that light and reflects others.
Exactly. Those reflected waves travel through the air and strike the retina in the back of your eye. There, specialized biological cells called cones absorb the energy of those waves,
triggering a chemical reaction that sends an electrical impulse down your optic nerve to your brain's visual cortex.
And that visual cortex finally processes the sensation we label red.
So redness is essentially a verb. It's not a static noun at all. It is an ongoing relational event.
Without the specific frequency of the photons, or the specific atomic arrangement of the paint, or the highly specific biological architecture of the human retina, the redness literally does not exist.
It is entirely contextual. It is a story told between light, molecular structure, and neurobiology.
If you change any single node in that relationship, like if the lighting changes to ultraviolet, or if a dog with different retinal cones looks at the chair, the property of color radically changes or vanishes entirely.
And Rovelli takes this macroscopic observation about color and argues that this deep relationality applies to every single property of matter at the quantum level.
Position, momentum, velocity, spin, none of these properties exist absolutely or independently.
A particle only possesses a position relative to another physical system it is interacting with.
In Rovelli's framework, to quote the core concept from the texts, things only exist thanks to, as a function of, with respect to, in the perspective of, something else.
So we are literally living in a universe of years. There are no standalone entities acting as anchors. There is just this endlessly shifting web of interactions.
And this relational, multifaceted, cubist view of reality was a deeply uncomfortable shock to the Western scientific establishment.
Oh, yeah. Einstein notoriously struggled with the implications of quantum theory until the day he died.
But, as our deep dive sources point out, This specific conceptualization of reality where objects dissolve into webs of relation would not have surprised certain philosophers living in ancient India and China.
The parallels are striking. When European physicists in the 1920s began realizing that the solid building blocks of the world were evaporating into probabilities and relational interactions.
They were inadvertently mathematically verifying ideas that had been rigorously debated in Eastern monasteries for millennia.
Let's shift our focus to antiquity, specifically looking at the 2nd century Buddhist sage Nagarjuna. This is a really crucial pivot in our sources.
Nagarjuna is arguably one of the most sophisticated philosophical minds in human history. He is the foundational figure of the Madhyamaka, or middle way school, of Mahayana Buddhism.
And the absolute cornerstone of his philosophical treatise is the concept of shunyata, right?
Yes.
Now, shunyata is usually translated into English as emptiness, and I think that specific translation is a semantic trap that derails a lot of people trying to understand this philosophy.
It's notoriously problematic. The English word emptiness carries so much heavy baggage. It implies a void, a literal vacuum, a bleak nothingness.
Pure nihilism.
Right. It sounds as if Nagarjuna is making the absurd claim that nothing in the universe exists at all. But his argument is vastly more subtle and intellectually rigorous than simple nihilism.
So what does he mean when he states that all phenomena are empty?
He is specifically saying they are empty of a concept called svabhava.
Svabhava. Let's define that. We can translate it as inherent existence or independent essence, I believe.
Or self-nature. Nagarjuna is arguing that if you look closely at any object, concept, or even your own identity, you will not find a solitary, unchanging, independent core that exists from its own side.
Nothing possesses an inherent essence that sustains itself independently of everything else.
Exactly. A phenomenon only arises, exists, and ceases conditionally, in strict dependence on its causes, its constituent parts, and the cognitive framework of the mind that perceives it.
This is the doctrine of dependent origination.
Furthermore, the Sanskrit root of the word shunya actually carries the connotation of being swollen or pregnant with possibility.
So shunyata is not a dead, dark void. It is a highly dynamic, fertile field of potentiality.
Because nothing is rigidly fixed with an absolute essence, change and interaction are actually possible.
Okay, I want to introduce some friction here, because taking this to its logical extreme can trigger a bit of an existential headache.
I can see that, yeah.
If we follow this logic, that things only exist in dependence on an observer or an interacting system, doesn't this just collapse into solipsism?
That's the most common pitfall when exploring these texts.
I mean, is Eastern philosophy, and by extension quantum mechanics, suggesting that the universe is just an illusion generated inside my head? To borrow that famous challenge Albert Einstein reportedly posed, if I close my eyes, does the moon suddenly disappear?
It is a critical question, but the answer to Einstein's challenge is definitively no. Solipsism, the idea that only your own mind is sure to exist, is an error. The moon does not vanish from the sky simply because a human being closes their eyes.
But if it lacks independent essence, if it's empty, how does it stay there?
We have to elevate our definition of what constitutes an interaction. The error lies in assuming that a human mind is the only valid frame of reference. It's not that the moon disappears without a conscious mind to observe it. It's that the moon's physical properties, its specific orbital velocity, its mass, its tidal influence, are entirely dictated and sustained by its ongoing physical interactions with the rest of the cosmos.
So the moon exists as a continuous set of relations with the gravitational curvature created by the Earth, the photons emitted by the sun, the microscopic impacts of micrometeorites.
Precisely. So if you were to magically erase the rest of the universe, delete the Earth, the sun, all the other matter, you wouldn't be left with a lonely, perfectly spherical moon floating in a dark void.
The very concept of the moon would cease to be mathematically or physically meaningful.
Without a gravitational field to relate to, its mass has no context. Without space to move through relative to another object, its momentum is undefined.
It has no inherent independent essence, no svabhava that allows it to exist outside of those vast cosmic relationships.
It is entirely empty of self-nature, perfectly mirroring Rovelli's physics.
To visualize this profound interdependence, our sources draw on a staggering metaphor from the Huayan school of Chinese Buddhism. It's known as Indra's net.
That metaphor visualizes the math of quantum theory remarkably well.
Let's delve into the mechanics of it. What does this net look like?
Indra's net is an image of breathtaking scale. Imagine a vast cosmic net stretching out infinitely in all directions, encompassing all of space and time.
Okay, I'm picturing it.
At every single node where the threads of this net intersect, a perfectly clear, multifaceted jewel is tied. Because the net itself is infinite in scope, the number of jewels is also infinite.
Right.
Now, if you lean in and examine any one individual jewel, you will see something remarkable reflected in its polished facets. You will see the reflections of all the other infinite jewels residing in the net.
But the geometry of the metaphor goes even deeper than that, doesn't it? Because every single jewel is reflecting every other jewel. The reflection you see in the first jewel contains the reflections of all the reflections.
It is a dizzying, infinite regression of mutual mirroring. You are looking at a fractal of total interconnectedness.
The structural logic of this image conveys that identity is entirely derived from interdependence. The part and the whole are ontologically inseparable.
You cannot alter, move, or remove a single jewel without the entire structural configuration of the infinite net instantaneously shifting in response. The nature of any single, isolated node is entirely dependent on the totality of the network.
And if we take that ancient, poetic Buddhist metaphor of the shifting net and apply it to the rigorous mathematics of modern physics, we find a direct, verifiable counterpart: quantum entanglement.
Entanglement is the actual physical mechanism that proves the universe operates like Indra's net.
Let's break down the mechanics of entanglement for you, learner, to show how strange this really is. Imagine a subatomic process that emits two particles simultaneously, say, two electrons.
Because they are born from the same event, their quantum properties are inextricably linked.
Let's use the property of spin. If one electron has a spin pointing up, the laws of conservation dictate the other must have a spin pointing down. They are entangled.
Right.
Now, you capture these two electrons. You keep one in a laboratory in New York, and you load the other onto a spacecraft and send it to a laboratory on Mars.
According to the rules of quantum mechanics, before you measure either particle, neither of them possesses a definite spin. They both exist in a superposition of being simultaneously spin up and spin down.
But the moment the physicist in New York measures their electron and forces it to collapse into a definite state, let's say it registers a spin-up, the state of the electron on Mars is instantaneously constrained.
At that exact same moment, the Mars electron becomes spin down.
And this phenomenon deeply disturbed Einstein. He famously derided it as spooky action at a distance.
Because it seemed to violate the absolute speed limit of the universe, the speed of light. I mean, how could the measurement event in New York possibly send a signal across millions of miles of space to tell the particle on Mars what state to assume and do it instantaneously?
The resolution to that paradox is even stranger than faster than light travel. The reality is, there is no signal traversing the space between them. They are not communicating at all.
And to understand why they aren't communicating, we have to look back at Indra's net.
How does the net explain it?
Once those two electrons become entangled, it is mathematically incorrect to treat them as two separate, independent entities. They no longer possess individual quantum states. They share a single, unified mathematical wave function.
They are behaving as two facets of a single underlying system.
Exactly. Just as pulling a single thread on Indra's net instantaneously reconfigures the geometry of the entire structure, measuring one particle instantly updates the reality of the whole entangled system.
Regardless of the spatial distance separating the measurement points. At the deepest, fundamental layer of physical reality, the spatial separation between New York and Mars is essentially an illusion.
That's exactly what.
If the basic building blocks of matter, the electrons, the quarks, are actually interconnected facets of a deeper, undivided reality, this naturally forces us to ask, what exactly does that deeper reality look like?
Where are these probability waves actually operating?
Right. And this specific question drove the work of one of the most profound thinkers in 20th century physics, David Bohm.
Bohm was a brilliant theoretical physicist, but he became deeply dissatisfied with the orthodox Copenhagen interpretation of quantum mechanics, which was championed by Niels Bohr.
The Copenhagen interpretation essentially argued that we shouldn't ask what is happening behind the scenes of the math, right?
Yeah, the prevailing attitude was basically shut up and calculate. They treated the math as merely a tool for predicting laboratory outcomes without requiring it to map onto an objective underlying reality.
But Bohm found that intellectually unacceptable. He demanded an ontology, a theory of what is actually existing and happening beneath the probability waves.
And through rigorous mathematical reformulation, known as pilot wave theory, And through extensive philosophical dialogues with thinkers like Jiddu Krishnamurti, Bohm developed a revolutionary cosmological framework.
He proposed the concepts of the explicate order and the implicate order. Let's delve into the mechanics of this framework.
Okay, so Bohm proposed that the world we navigate every single day, the macroscopic world of solid chairs, distinct trees, ticking clocks, and apparently separate subatomic particles in the lab, is the explicate order.
The word explicate literally means unfolded, right?
Unfolded, yes.
Wow.
It is the visible, unfolded reality where things appear separate and space and time dominate.
But Bohm argued with mathematical precision that this explicate order is merely a secondary projection.
It is a localized expression of a vastly deeper, hidden, undivided, higher dimensional reality, and that deeper dimension is the implicate order. The prefix implicate means enfolded.
So in the implicate order, the concepts of separate space and sequential time lose their absolute meaning. Everything is enfolded into everything else, forming a single, unbroken wholeness.
Our sources highlight an analogy that Bohm meticulously constructed to help laypeople visualize this: the relationship between the implicate and explicate orders.
It's the fish tank analogy, and the geometry of it is brilliant. Imagine a large rectangular glass fish tank. Inside the tank, swimming through the water, is one single fish.
Just one fish.
Now imagine you have an intricate camera setup. Camera A is pointing directly at the front pane of the glass. Camera B is pointing at the side pane of the glass.
So you have two entirely different two-dimensional perspectives capturing the exact same three-dimensional system.
Exactly. Now we take a person who has absolutely no concept of what a fish tank is, and we place them in a separate, isolated room. We sit them down in front of two television monitors.
Monitor A displays the live feed from the front camera. Monitor B displays the live feed from the side camera.
If this observer doesn't know any better, they are going to look at those two screens and naturally conclude they're watching two completely separate, distinct aquatic creatures.
Because the visual data supports that conclusion. The creature on monitor A is seen head-on, maybe looking wide and flat. The creature on monitor B is seen in profile, displaying a long fin and a tail. They look like different entities.
But as the observer watches, they notice a bizarre, deeply unsettling pattern. Whenever fish A suddenly darts to the left, fish B executes a perfectly coordinated, corresponding movement.
Right.
Whenever fish A turns its face directly toward the lens, fish B is simultaneously seen perfectly in profile. To the uninitiated observer, this looks like magic.
It looks like instant, faster-than-light telepathic communication between two separate entities residing in two different locations, which perfectly maps onto how quantum entanglement appears to physicists measuring particles in a laboratory.
It looks like spooky action at a distance. But the observer's confusion stems from a lack of dimensional awareness. The reality is there is no communication whatsoever happening between monitor A and monitor B.
There are not two fish. There is only one fish existing in a higher dimensional reality, the three-dimensional volume of the tank.
The two television screens are merely two-dimensional projections of that single, undivided reality.
And Bohm is arguing that entangled particles like our electrons in New York and Mars are exactly like the images on those screens.
They appear separate to our instruments operating within 3D space, but their entanglement is proof that they are actually projections of a single, unified reality residing in the higher dimensional implicate order.
It requires a profound, almost dizzying shift in perspective to view reality this way. And to further demonstrate how matter functions within this paradigm, Bohm utilized another incredibly vivid mechanical metaphor.
The ink drop in the glycerin.
Yes, imagine a large, clear glass cylinder. Inside it is a slightly smaller glass cylinder. The narrow space between the two walls of glass is filled with highly viscous, thick, clear glycerin fluid.
A setup specifically designed to observe fluid dynamics.
Now, using a fine dropper, you carefully inject a single concentrated drop of black ink directly into the clear glycerin.
So we have a distinct, bounded, separate object, an explicate entity.
Now, the experiment begins. You take the inner glass cylinder and slowly begin to rotate it clockwise. As the cylinder turns, the thick glycerin is stretched and pulled.
And the discrete drop of ink gets caught in this mechanical shearing force.
It begins to smear. It stretches out into a thin, dark thread, winding around the cylinder. As you continue to rotate the glass, say, 10 full rotations, the thread of ink becomes so incredibly thin and dispersed that it completely vanishes from sight.
The glycerin appears totally clear again, but the ink hasn't been destroyed. It hasn't left the system.
No, the ink is still entirely present in the fluid. However, it has been thoroughly mixed. Its order has changed, It has become enfolded into the entire system.
The separate, distinct drop no longer exists in the visible explicate order. It is now hidden, dispersed throughout the implicate order of the glycerin.
And this is where the mechanical magic trick happens. If you simply reverse the mechanical process, if you rotate the inner cylinder counterclockwise for exactly 10 turns, the fluid dynamics reverse.
That invisible, globally smeared thread of ink will slowly gather back together.
It sequentially unfolds from the implicate order, and suddenly, astonishingly, the distinct, highly concentrated black drop of ink reappears in the explicate order.
It is a phenomenal visualization. Bohm is suggesting that the subatomic particles we think of as the permanent, solid building blocks of reality, the protons, the neutrons, the electrons, are not tiny billiard balls.
They're like that ink drop. They're
Yeah.
constantly unfolding into the unseen, higher dimensional implicate order, and then rapidly unfolding back into the visible explicate world.
Matter is not a static substance. Matter is an ongoing dynamic process of enfolding and unfolding.
And this specific realization that matter is a transient, rhythmic manifestation of an underlying dynamic field is where the dialogue between modern high-energy physics and ancient mysticism reaches an absolute poetic crescendo in our sources.
Let's bring in the physicist Fritjof Capra here. In his landmark 1975 book, The Tao of Physics, Capra drew a massive, highly detailed comparative line between quantum field theory and the mythological frameworks of Hinduism.
Capra analyzed the fact that in modern quantum electrodynamics, subatomic particles are not permanent fixtures. They are fleeting, transient concentrations of energy.
They are constantly coming into existence and annihilating themselves back into the quantum vacuum.
And it is vital to understand that the vacuum in quantum physics is absolutely not empty space. According to the uncertainty principle, the vacuum is a boiling, seething soup of extreme potential energy, characterized by constant quantum fluctuations.
Exactly. The vacuum is dynamic. And Capra realized that this view of matter as a continuous, rhythmic, almost violent process of creation and destruction emerging from a fertile void perfectly mirrors one of the most powerful and enduring visual archetypes in Hindu mythology.
The cosmic dance of the god Shiva, specifically the form known as Nataraja, the lord of the dance.
Let's paint this visual comparison for you, the learner, because the juxtaposition of ancient art and modern data is staggering.
Our sources specifically point to the stunning 10th and 12th century Chola dynasty bronze statues of Shiva found in southern India.
Imagine a magnificent, intricately cast bronze figure of Shiva balancing on one leg, dancing wildly within a circular arch of flames. He possesses 4 arms, positioned in a perfect geometry of dynamic perpetual motion.
In his upper right hand, he holds a small hourglass-shaped drum called a damaru. That drum symbolizes the primal, rhythmic sound of creation, the vibration that calls the physical universe into being.
In his opposing upper left hand, he holds a fierce tongue of flame. That fire represents the energy of destruction, the force that ultimately dissolves the universe back into the formless void.
The mythology explicitly portrays creation and destruction not as separate sequential eras, but as a perfectly balanced, ceaseless, simultaneous dance.
Now, Capra takes that magnificent 10th century bronze statue and he places it side by side with a photograph taken in the 20th century, a photograph from a bubble chamber at CERN.
The massive particle physics laboratory in Switzerland.
Right. In a bubble chamber, physicists smash high-energy particles together inside a superheated fluid. As the particles collide and shatter, they leave visible microscopic trails of bubbles.
These photographs capture an absolute explosion of chaotic tracks. Spirals, tight curves, and jagged lines appearing spontaneously out of the vacuum and vanishing just as quickly in tiny flashes of annihilation.
Those tracks are the signatures of virtual particles. You are seeing protons emitting and instantly reabsorbing pions. You are seeing electron-positron pairs violently springing into existence from pure energy.
Only to instantly annihilate each other in a fraction of a microsecond.
Capra places the statue and the photograph together and points out the profound resonance. He argues that the bubble chamber photograph is not capturing passive dead matter.
It is capturing a literal, violent, microscopic dance of creation and destruction. The quantum vacuum is dancing the universe into and out of existence millions of times a second.
Capra suggests that the anonymous bronze sculptors of 1,000 years ago and the physicists operating a billion-dollar super collider today are expressing the exact same fundamental intuition about the rhythmic, process-oriented nature of reality.
It is all a continuous cosmic dance.
The imagery Capra invokes is undeniably poetic, and the aesthetic resonance between the mythology and the physics is awe-inspiring. But I mean, we're rapidly approaching a dangerous intellectual precipice here.
Oh, absolutely. I can feel the brakes being applied.
They must be applied with maximum force right now because it is precisely here, mesmerized by the sheer beauty of these sweeping metaphors, that the critical danger lies.
When a narrative starts blending the mathematics of the quantum vacuum with concepts of cosmic consciousness, dancing gods, and the universe as a mystical web of living energy, it becomes exceptionally easy to abandon rigorous scientific methodology.
And slip into totally unsupported pseudoscientific wishful thinking?
Yes. Let's step firmly into the critical side of this deep dive. We need to analyze the trap of quantum flapdoodle.
Back to Gell-Mann's terminology.
It perfectly captures the frustration of the physics community. Our sources lean heavily on the critical work of physicists like Victor Stenger, who authored the book Quantum Gods.
Their entire mission is to enforce a boundary, right? To separate legitimate philosophical complementarity from the predatory billion-dollar industry of New Age pseudoscience.
Precisely.
All right, I'm going to play devil's advocate here on behalf of the listener because these pseudoscientific ideas are everywhere. They dominate algorithms. I have seen the documentaries. I have perused the self-help aisle.
They're pervasive, yeah.
Here is the popular narrative. If quantum mechanics mathematically proves that observation creates reality by collapsing the probability wave function, and ancient Eastern philosophy like the Yogacara mind-only school of Buddhism states that the mind creates the world.
I see where this is going.
Why can't I synthesize those two facts? Why can't I use the laws of quantum physics to mentally manifest $1 million into my bank account?
Right.
This is the explicit premise of massively successful media like the film What the Bleep Do We Know? Or the extensive catalog of books by authors like Deepak Chopra.
Yes, they assert that you possess a quantum mind, and your conscious intentions can directly shape physical reality at the subatomic level.
So why is that logically invalid?
It is logically invalid because it is built on a fundamental systemic misunderstanding of the physics vocabulary. It relies entirely on what the scientific community calls the anthropocentric observer fallacy.
Let's meticulously dismantle that fallacy. What does observer actually mean in a laboratory setting?
The entire misunderstanding hinges on the semantic baggage of the word observation. In everyday colloquial English, when we use the word observation, we implicitly mean a human being consciously looking at something.
We associate the act of observing with possessing a mind, having awareness, and holding an intention.
So when the founding quantum physicists wrote papers stating the act of observation collapses the quantum wave function into a definite state, lay people naturally, but incorrectly, assumed.
My conscious human mind is what is collapsing reality into existence.
Exactly. Which sounds incredibly empowering. It flatters the human ego immensely to think the universe requires our consciousness to render itself.
It is flattering, but it is physically false.
Completely false. In the strict mathematical formalism of quantum mechanics, an observation or a measurement absolutely does not require a conscious human mind.
It does not require a biological brain at all. An observation is simply a term for a physical interaction between a quantum system and a macroscopic system.
An interaction. So any exchange of energy or information, there is a well-understood, mathematically rigorous physical process called decoherence.
Walk us through decoherence.
Imagine a single photon of light traveling through the emptiness of deep space. It exists as a wave of probabilities. If that photon eventually strikes the surface of a jagged rock on a totally lifeless, barren planet on the far side of the Andromeda Galaxy.
That physical impact constitutes an interaction.
Yes. That impact causes environmental decoherence. The photon's wave function collapses. Its position becomes definite. Reality is rendered.
And absolutely no human being, no consciousness, no spiritual intention, and no mind was required for that physics to occur.
Equating a mathematical wave collapse mechanism with human intention is a complete categorical misreading of the science.
But wait, let's look at the most famous quantum thought experiment in history, Schrödinger's cat.
Oh boy, yes.
Everyone knows the setup. A cat is placed inside a sealed steel box along with a radioactive atom, a Geiger counter, and a glass vial of lethal hydrocyanic acid.
If the atom decays, the vial breaks, the cat dies. If the atom doesn't decay, the cat lives.
Because the atom's decay is a quantum event governed by probability, the popular interpretation is that the cat exists in a suspended state of being both dead and alive simultaneously until a conscious human being opens the box and looks inside.
Right, that's the pop culture version.
Doesn't that explicitly prove that human consciousness is the key to rendering reality?
This represents one of the most agonizing ironies in the entire history of physics. Erwin Schrödinger did not create that thought experiment to prove that consciousness creates reality.
He didn't?
No. He created it specifically to mock how utterly absurd the Copenhagen interpretation was.
Wait, he was being sarcastic. The most famous quantum parable is literally a piece of academic satire.
Yes. Schrödinger was deeply frustrated with his colleagues. He was trying to mathematically demonstrate how ridiculous their theory became if you attempted to scale up the rules governing subatomic particles and apply them to macroscopic, everyday objects.
He was essentially arguing, look at the logical conclusion of your math. If we apply your rules to a cat, we get a cat that is both dead and alive at the same time, which is patently ridiculous.
Exactly. He was pointing out a fatal flaw in the theory's boundary conditions, not writing a spiritual manual for how human observation manifests reality.
And it wouldn't be in a superposition anyway because of decoherence, right?
Exactly. The cat itself is a massive macroscopic system, composed of trillions upon trillions of interacting atoms. The cat is constantly measuring itself.
It is interacting with the air molecules in the box, the metallic floor, its own internal biology.
Environmental decoherence is happening constantly, instantaneously. The system collapses into a definite state, dead or alive immediately. The cat is never hovering in a mystical superposition, waiting for a human to open the lid.
Okay, I concede that I cannot use quantum wave collapse to magically manifest $1 million. But what about human relationships?
Here we go.
There is a massive trend online claiming that quantum entanglement explains concepts like soulmates or deep emotional telepathy.
I've seen those videos, yeah.
The narrative suggests that if two people fall deeply, passionately in love, their neural pathways become quantumly entangled. Because of spooky action at a distance, they can feel each other's pain or emotions across the globe instantly.
Once again, it is a beautifully poetic sentiment, but it is scientifically impossible based on everything we know about thermodynamics and neuroscience.
But wait, before you entirely dismiss macroquantum effects in biology, I need to introduce some friction here. What about the emerging field of quantum biology?
It's a fascinating field, true.
There is credible research suggesting that European robins utilize a protein in their eyes called cryptochrome to sustain quantum entanglement, allowing them to visibly see the Earth's magnetic field for navigation.
And photosynthesis, right.
Yeah, plants use quantum coherence to map the most efficient route for energy transfer in the FMO complex. If birds and plants are using quantum mechanics, why are you so quick to dismiss the human brain doing it?
That is a highly sophisticated counterargument, and quantum biology is indeed a revolutionary frontier. However, we have to look closely at the specific boundary conditions of those biological examples.
What's the difference?
The quantum effects observed in photosynthesis or avian navigation are highly localized, extremely specialized phenomena occurring at the nanoscale. And crucial point, they operate over timescales of femtoseconds.
Fractions of a billionth of a second. They are fleeting.
Extremely fleeting. Quantum entanglement is an incredibly fragile state. To maintain sustained, measurable entanglement in a physics laboratory, scientists have to isolate particles in near-perfect ultra-high vacuums.
And cool them down to temperatures approaching absolute zero to prevent any random thermal energy from disrupting the system.
Now compare that pristine, freezing laboratory environment to a human brain.
The brain is basically the opposite of a vacuum.
The human brain is a massive, wet, incredibly hot, overwhelmingly noisy biological reactor. The sheer thermal energy and the ceaseless chaotic barrage of molecular interactions occurring in the brain guarantee rapid decoherence.
The environment is simply too noisy.
Sustaining a coherent, quantum-entangled state across the spatial distance of two macroscopic human brains for any meaningful duration of time is physically impossible under the current laws of thermodynamics.
You may share a profound, beautiful emotional connection with your partner, but that connection is mediated by classical neurochemistry, the complex interplay of dopamine, oxytocin, serotonin, and behavioral psychology.
It is not mediated by quantum entanglement.
The synthesis here requires extreme caution. We have to acknowledge that empirical science and Eastern philosophy operate in entirely different, though complementary, domains.
Science is an empirical, predictive enterprise grounded in strict mathematical formalism. Its goal is to objectively describe the mechanistic behavior of the physical universe.
While Eastern philosophy, particularly Buddhism, is fundamentally soteriological.
Soteriological, meaning its primary objective is salvation, or, in the Buddhist framework, the systematic alleviation of human suffering through psychological insight.
It's concerned with investigating the nature of the mind to dismantle the illusions that cause us pain. If we recklessly equate a mathematical probability wave in a Schrödinger equation with a spiritual vibration or a karmic energy field, we aren't creating a grand unified theory.
No, we are actually flattening and disrespecting the rich, rigorous complexities of both traditions. As one of our sources eloquently points out, this intellectual sloppiness leads to the conflation of metaphorical similarities with strict ontological equivalence.
Physics and philosophy are complementary lenses that can disrupt our rigid classical view of the world, but they are not speaking the exact same language.
The goal should be complementarity without conflation. We can appreciate the aesthetic and conceptual rhymes without pretending they are the exact same equation.
So, we arrive at the ultimate question for you, the learner. If I can't use quantum physics to manifest a sports car, and I can't use entanglement to telepathically communicate with my soulmate, why does any of this intensely abstract physics and ancient philosophy actually matter for your daily life?
If it doesn't grant magical superpowers, what is the practical, real-world resonance of this deep dive?
Exact.
The resonance is massive, because even when we strip away the New Age pseudoscience, the genuine, verified insights from both relational quantum mechanics and the Eastern philosophical traditions offer a profoundly transformative new framework.
A framework for how we construct our identity, how we navigate social interactions, and how we view our ethical responsibilities to the planet.
To explore this practical application, I want to introduce a concept we haven't touched on yet. Fritjof Capra highlights a fascinating structural parallel between the ancient Chinese I Ching, or the Book of Changes, and a specific framework in physics known as S-matrix theory.
Let's start with the physics to ground this. What exactly is S-matrix theory?
S-matrix stands for scattering matrix. It was a theoretical tool championed by physicists like John Archibald Wheeler and Werner Heisenberg. It emerged when physicists were struggling to map the exact, continuous paths of subatomic particles during violent collisions.
The S-matrix approach essentially admits defeat on mapping the exact internal mechanics. It treats the collision event as a black box.
Instead of trying to define the specific objects inside the box, the mathematics focus entirely on mapping the probabilities of the initial input states against the resulting output states.
So it abandons the attempt to track solid objects and instead mathematically models the process of scattering itself. The interaction is the primary reality, not the particles.
Exactly. It maps the dynamic tendencies for change, rather than cataloging static entities.
And this mathematical approach to reality, focusing on the probabilities of transition, perfectly mirrors the fundamental philosophy of the I Ching.
The I Ching does not view reality as a collection of static things. The foundational reality is the continuous flowing process of the Tao.
The famous hexagrams of the I Ching are not symbols of fixed objects. They represent archetypal patterns of dynamic change and transformation.
The focus is entirely on understanding the trajectory of the process.
I want to challenge you, the listener, to actively apply this S-matrix Taoist framework to your own life. Think about how much immense psychological suffering we inflict upon ourselves because we insist on viewing our identities, our careers, and our relationships as static, solid objects.
We tell ourselves, I am definitively this type of person, or my career trajectory must look exactly like this solid plan.
We constantly try to freeze the fluid universe into a Newtonian state. But if we accept the reality proposed by both quantum physics and the I Ching, life is not a fixed identity. It is a continuous, fluid process of transitions.
You are not a static noun. You are an unfolding verb.
Viewing oneself as a verb rather than a noun is a highly practical psychological intervention, and we see this relational, fluid worldview applied structurally to societal dynamics as well.
Our sources bring up the work of Gregory Howell and his Tray of Life methodology. Howell explicitly imports the conceptual insights of relational quantum mechanics to diagnose and treat human social friction in corporate and community settings.
He connects these physics concepts to the Zen Buddhist symbol of the unso.
The unso is the iconic, traditional Japanese hand-drawn circle executed in a single, fluid brushstroke. It is a profound symbol representing enlightenment, the entirety of the universe, and importantly, the void.
That dynamic emptiness, shunyata, pregnant with possibility that we discussed earlier.
Exactly. Howell maps this concept of an interconnected empty circle, along with Rovelli's relational physics, directly onto the mechanics of Japanese social structures.
Let's ground that with a specific cultural example. How does this look in practice?
Let's examine the foundational Japanese cultural concept of wa, which loosely translates to group harmony. or the senpai-kohai dynamic, which is the deeply ingrained mentor-mentee, senior-junior relationship that dictates interaction in Japanese schools and corporations.
If we analyze a society using a Western classical Newtonian mindset, we view the community as a mere collection of isolated, independent atoms colliding with one another.
It is a highly individualistic framework. I have my absolute boundaries, you have yours.
And when those rigidly defined, independent atoms inevitably bump into each other, you generate social friction and conflict.
Inevitably. But if we adopt the relational framework, whether viewed through the lens of Rovelli's quantum interactions or the Zen understanding of dependent origination, the paradigm shifts entirely.
The individual ego does not exist independently of the group structure. Identity is entirely formed by the interactions.
A senpai, the senior mentor, only possesses the identity of a senpai in direct relation to the existence of a kohai, the junior mentee. Their identities are mutually co-arising.
Like the entangled electrons or the reflection in Indra's net.
When individuals stop conceptualizing themselves as isolated objects fighting for territory and start recognizing themselves as relational nodes inextricably linked in a larger dynamic net, the entire basis for social friction begins to dissolve.
The maintenance of harmony of the Wa is structurally prioritized because the relationship itself is understood to be the primary reality, not the isolated defensive ego.
That conceptual shift completely alters the geometry of how you walk into a crowded room or how you navigate a tense, high-stakes meeting at work.
You aren't an isolated classical object furiously defending your borders against other objects. You are a dynamic node participating in an ongoing interaction. Your identity in that room is co-created by everyone else in it.
And the implications of this worldview extend far beyond the boardroom. We can logically extrapolate this relational framework to a planetary ecological scale.
Our sources include a fascinating, structurally rigorous essay titled Humanimals of Earth.
It argues that if the universe is fundamentally an interconnected relational hallmark, whether you prove that through Bohm's implicate order physics or through the Buddhist doctrine of interpenetration, this structural reality demands a massive, unavoidable ethical shift in how we inhabit the planet.
An ethical imperative derived directly from the mechanics of interconnectedness.
Think about the destructive consequences of the classical Western worldview. The Newtonian paradigm inherently separated human beings from the natural world.
We positioned ourselves as the rational, isolated observers standing outside the giant clockwork mechanism, objectively looking in.
This intellectual separation justified a deeply destructive framework where nature, the broader biosphere, and animal life were categorized as the other.
They were viewed merely as external resources to be measured, dominated, extracted, and exploited for the benefit of the isolated human subject.
Because they were fundamentally separate from us.
Yeah.
But if modern physics and ancient philosophy are correct, and there is absolutely no fundamental separation,
If the observer is inextricably, physically, and mathematically woven into the fabric of the observed, if my very biological and conceptual existence is relationally defined by the total ecosystem around me,
and the exploitation of the other logically becomes a direct form of self-harm.
you cannot poison the well if you are the water.
An understanding of deep relationality forces an ethic of what the author of the essay terms reciprocal togetherness. It's not a preachy moralistic stance, it is a structural reality.
You cannot abuse the environmental network without mathematically and philosophically abusing the very infrastructure that generates and sustains your own identity.
Ecological responsibility becomes indistinguishable from self-preservation.
It is a profound, heavy responsibility to recognize our interconnectedness. But I also want to highlight that summarizing all of this, realizing our deep emptiness, our total lack of absolute, independent, isolated existence, is actually an incredibly liberating psychological insight for the individual.
I agree, the psychological implications are profound. Walk us through how you see that liberation playing out.
Think about the sheer volume of psychological and emotional energy we expend every single day trying to build, reinforce, and aggressively defend our ego.
It's exhausting.
We work exhaustingly hard to construct this solid, unchanging, bulletproof version of me. We defend our opinions, our status, our self-image, as if they are permanent physical structures under siege.
But if both the bleeding-edge equations of quantum physics and the ancient wisdom of the sages agree that no such solid, independent thing exists,
we can finally put down our armor. We can stop trying so desperately hard. We don't have to violently defend a rigid border because, fundamentally, the border is an illusion.
we exist only in our interactions. We are the flow. We are the dance.
And recognizing that Truth, letting go of the exhausting illusion of the solid, isolated self, is the very mechanical definition of liberation.
The dissolution of the rigid Newtonian ego as the ultimate pathway to psychological serenity. It is a powerful, elegant synthesis of the empirical science and the soteriological philosophy.
It really is. So let's take a moment to recap the staggering intellectual journey we've been on today. We started our deep dive in the 1920s with Werner Heisenberg pacing the wind-battered shores of Helgoland.
Mathematically shattering the comforting Newtonian clockwork universe and unveiling a subatomic world governed by probabilities and unresolvable uncertainties.
We utilized the fragmented, multifaceted lens of Cubist art to visualize how reality is fundamentally contextual.
Leading us to Carlo Rovelli's radical assertion that the universe contains no absolute objects whatsoever, only an endless web of relations.
We traveled back thousands of years to the monasteries of ancient India and China, discovering that Nagarjuna's rigorous concept of sunyata, the emptiness of inherent essence,
And the dizzying cosmic interconnectedness visualized in Indra's net perfectly, conceptually prefigured these modern quantum revelations.
we explored David Bohm's profound pilot wave framework, recognizing that the seemingly separate objects in our explicate order are actually projections of a vastly deeper, undivided reality.
An implicate order perfectly mirrored by the mythological cosmic dance of Shiva and the churning, fertile chaos of the quantum vacuum.
He carefully navigated the treacherous waters of quantum flapdoodle, deploying the mechanics of environmental decoherence to ensure we didn't mistakenly confuse a mathematical wave collapse with mystical, ego-driven manifestation.
And finally, we grounded these abstract theories, demonstrating how adopting a relational S-matrix worldview can actively dissolve our social friction.
Revolutionize our ecological relationship with the planet, and ultimately provide a pathway to inner peace.
It is a completely revolutionized way of perceiving the universe.
But before we conclude this deep dive, learner, we want to leave you with one final provocative thought. Something to chew on that pushes these concepts just a little bit further toward their uncomfortable logical limits.
If we synthesize this journey and take Carlo Rovelli's physics and Nagarjuna's philosophy at their absolute literal word,
Okay.
if it is structurally true that things only exist in their relations and interactions with other things, we must ask, what happens to our fundamental sense of self when we are completely, totally isolated?
That is a deeply unsettling premise.
Follow the logic. Imagine you are placed inside a perfect, theoretically flawless sensory deprivation chamber. There are 0 photons of light to interact with the rhodopsin in your retinas.
There are 0 sound waves to interact with the tympanic membrane of your eardrums.
There is no tactile feedback, no gravity, no thermal exchange. And crucially, there are no social interactions to continually define your relational role as a friend, a worker, or a partner.
So, if there is absolutely no observer and no environment whatsoever to interact with, does the entity you call you still physically or conceptually exist?
Because if there is no interaction, there can be no definitive property. To take that a step further, is it possible that your memory, your ceaseless internal monologue, is simply a biological coping mechanism acting as the necessary internal other?
Is your brain continuously forced to generate an internal interaction, literally talking to itself just to provide the relational friction required to keep the quantum wave function of your identity from dissolving entirely back into the void?
That's something to think about.
That reframes the entire concept of human consciousness. Are we just desperately, constantly interacting with our own memories simply to prove to the universe that we exist? That thought is going to echo in my mind for a long time. Learner, thank you so much for investing your time and joining us on this incredibly dense, profound deep dive.
It's been a journey.
The universe is weirder, wilder, and vastly more interconnected than it ever appears on the macroscopic surface. So the next time you look at a simple, everyday object, even just the chair you are sitting on, we hope you can see past the solidity and see the intricate cosmic dance happening beneath. Keep questioning the reality right in front of your eyes.